Why are there helicopters with a rotor on top of your head while the Russian Kamov series uses double-layer rotors? You might think it's just an old man showing off his skills, but actually, they are playing the rules of physics to the extreme. Like a regular helicopter, one main rotor is responsible for the lift, but the fuselage will want to turn the opposite way because of the reaction torque. So, you must add a small tail rotor on that long tail to push back. Here comes the problem. This rotor is not only a huge fuel eater, but it doesn't provide any vertical lift. Instead, it wastefully consumes 10% to 15% of the engine's power. Not only that, it's also very fragile. Crash records since the Vietnam War show that up to 75% of helicopter accidents are caused by the tail rotor or its fragile rear drivetrain. Once the tail is broken on the battlefield, the helicopter immediately turns into a crazy spinning top. How do the Russians solve it? Simple and rude. They just ditch the tail rotor and stack 2 layers of rotors overhead. 2 rotors, one above the other one spinning clockwise, one counterclockwise, facing each other. The torque cancels itself out internally. It's called a coaxial twin rotor. In this way, 100% of the engine's power is focused on vertical lift and maneuvering. To intuitively feel this power dividend, you can compare them. Take the Mi-8 and the Ka-52, using the exact same engines. With the same engine power, the traditional layout of the Mi-8 can only lift 3.5 to 4 tons. The Ka-52 can easily lift 5 tons of external cargo. You might ask, how do you turn a coaxial twin rotor without a tail? The answer is differential torque. The computer adds resistance and torque to one rotor layer while reducing it on the other. With the same total lift, use that torque difference to make the helicopter flick its head sensitively. Not only that, it also comes with an energy recovery effect. The lower rotor can reuse the vortex airflow generated by the upper rotor, boosting efficiency directly. The result is like the system is cheating. With the same 2 engines, Kamov's power efficiency is about 20% higher. The structural dividend of this efficient tailless design is further amplified in actual combat. Without the long tail beam, it is 25% to 30% shorter than a helicopter of the same class. It's not only perfectly suited for narrow warship decks, but when traveling between city towers or forests, it completely eliminates the hidden danger of clipping wires with the tail rotor. In terms of mobility, it is completely unrestricted by crosswinds and has an extremely fast cornering response. The Ka-50 can even quickly snap its nose in place to target airborne threats with its fixed guns. At the same time, with the advantage of using every bit of power, the Kamov series still holds world records for helicopter climb rates. But there is no free lunch in this world. The first cost of a double-layer rotor is a ridiculously complex mechanical structure. In order to control the upper and lower rotors, you have to stuff in 2 sets of swash plates and concentric shafts. Core components like the gearbox not only have to assign the massive horsepower of 2 engines to concentric axes, but the interior is also packed with complex planetary gears. Maintenance can drive ground crews crazy, and the lifetime cost is extremely high. The second price is the fatal hidden danger caused by stacking the rotors. To prevent the 2 sets of blades from hitting each other in the air, designers have to desperately increase the height of the rotor mast, but that has immediate side effects. That huge, complex rotor head flying at high speed creates amazing parasitic drag. It can even account for half of the total drag of the entire aircraft. Worst of all, even with all that resistance and compromise, the risk of a crash remains. If you fly at high speeds over 250 kilometers per hour or perform extreme maneuvers larger than 3G, the upper and lower blades can easily collide in mid-air. To save lives, designers must use high modulus composites for extreme rigidity, along with strict computer-controlled flight limits. So, coaxial twin rotors aren't a question of which is more advanced. It's the ultimate hardcore trade-off. The Russians maintain it with hellish machinery and deal with amazing aerodynamic drag in exchange for extreme power efficiency and survival maneuverability. If you were a helicopter pilot, would you want the simplicity and peace of mind of a traditional layout, or the violent aesthetics of the coaxial design? Welcome to share your opinion in the comments.